Welcome to Math Contest Drills for Filipino Kids. In this presentation, let us show the solution to MTAP 2024 Elimination Round for Grade 10 students. This is part 3 of 5 parts, numbers 21 to 30. Give all fractions and ratios in lowest terms. All denominators should be rationalized. Express all equations of lines in the form ax plus by plus c equals 0, where a, b, and c are integers and a is greater than 0. Figures given are not drawn to scale. Number 21. One of the roots of 2x to the 5th power minus 17x raised to the 4th power plus 45x cubed minus 28x squared minus 44x plus 48 is 2. Find the sum of all positive roots. For our solution, let us use the synthetic division. First, let us get the coefficients of the given polynomial. We have 2, negative 17, 45, negative 28, negative 44, and then 48. Since 2 is a root, let us use 2 as our divisor. Bring down 2. Then we have 2 times 2 is 4 plus negative 17, that is negative 13. Then negative 13 times 2 is negative 26 plus 45, that is 19. So we have 19 times 2, 38. Plus negative 28, that is 10. 10 times 2 is 20, plus negative 44, that is negative 24. Then negative 24 times 2 is negative 48 plus 48. Since 2 is a root, we have 0. Next, let us use 2 again as a divisor. So we bring down 2, then 2 times 2 is 4 plus negative 13, that is negative 9. Negative 9 times 2 is negative 18 plus 19, that is equal to 1. 1 times 2 is 2 plus 10, that is 12. Then we have 12 times 2 is 24 plus negative 24, that is 0. Next, let us use negative 1 as a divisor. Then bring down 2. 2 times negative 1 is negative 2 plus negative 9, that is negative 11. Negative 11 times negative 1 is positive 11 plus 1, that is 12. Then 12 times negative 1 is negative 12 plus 12, that's a 0. Negative 1 is also a root of the given polynomial. Since we have 3 non-zeros in the quotient, let us have the quadratic expression equivalent to this. That is 2x squared minus 11x plus 12. This may be factored as 2x minus 3 times x minus 4. Hence, in this quadratic equation, we have 3 halves as a root, also 4 as a root. Then we can get the sum of all the positive roots, that is 2 plus 2 plus 3 halves plus 4, and this is equal to 9 and 1 half. The sum, therefore, is 9.5. Number 22. If 5x cubed plus 41x squared plus 111x plus 101 equals a times x plus 3 cubed plus b times x plus 3 squared plus c times x plus 3 plus d, find the values of a, b, c, and d. For our solution, let us expand the right-hand side of the given equation. So we have a times x cubed plus 9x squared plus 27x plus 27 plus b times x squared plus 6x plus 9. Then we have cx plus 3c plus d. We have ax cubed plus 9a plus b x squared plus 27a plus 6b plus cx. Then we have 27a plus 9b plus 3c plus d. Comparing the terms in the resulting expression on the right-hand side to the expression on the left-hand side of the equation, we have a is equal to 5. Then we have 9a plus b is equal to 41. Then b is equal to 41 minus 9 times 5, that is 45. Then we have b is equal to negative 4. Next, we have 27a plus 6b plus c equals 111. Then we have 111, or c is equal to 111 minus 27 times 5, that's 135. And 6 times b, that is 6 times negative 4, negative 24. Then we have plus 24. Hence, c is equal to 0. Lastly, we have 27a plus 9b plus 3c plus d is equal to 101. Then we have d is equal to 101. 27 times 5 is 135, so we have minus 135. 9 times negative 4 is negative 36, then we have plus 36. 3 times 0 is 0, then d is equal to 2. So we have a equals 5, b equals negative 4, c equals 0, and d equals 2. Number 23. Given 2 points A, negative 1, 7, and B, 2, 3, find the length of segment AB. For our solution, we will use the formula for distance between 2 points. That is, d is equal to the square root of x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. Substituting the coordinates of the 2 points, then we have 2 minus negative 1 squared plus 3 minus 7 squared. So we have the square root. 2 minus negative 1 is 2 plus 1 squared, so that is 9. 3 minus 7 is negative 4 squared, that is 16. Then we have the distance between points AB, that is the length of segment AB, equal to the square root of 25, that is equal to 5 units. Number 24. Given 2 points A, negative 1, 7, and B, 2, 3, find C, the midpoint of segment AB. For our solution, we will use the formula for midpoint. That is, C is equal to, or C has the coordinates x sub 1 plus x sub 2 divided by 2, and y sub 1 plus y sub 2 divided by 2. So we have the coordinates of C as negative 1 plus 2 over 2, comma, 7 plus 3 over 2, So the coordinates of C, the midpoint of segment AB, is 1/2, 5. Number 25. Line L has the equation 3y equals 4x plus 7. Point A has coordinates 3, negative 5. Find the equation of the line that is perpendicular to L and passes through A. For our solution, let us rewrite the equation of L in standard form. That is 4x minus 3y equals negative 7. Hence, the equation of the line perpendicular to this line has 3x plus 4y equals 3 times 3 plus 4 times negative 5. And this is equal to 9 minus 20. Then the equation of the line perpendicular to L passing through A is 3x plus 4y equals negative 11, or 3x plus 4y plus 11 equals 0. Number 26. How many integers x satisfy 3x plus 4 squared times x minus 2 times x plus 5 is less than or equal to 0? For our solution, let us get the critical numbers for this given inequality. We have negative 4/3, negative 5, and positive 2. Negative 4/3 is a 0 of multiplicity 2. Then we have negative 5, negative 4/3, and positive 2. Let us get the factors of the expression in the left-hand side of the inequality. 3x plus 4 is a factor twice, or 2 times. Then we have x minus 2, then we have x plus 5. When x is equal to negative 5, x plus 5 is 0. When x is equal to negative 4/3, 3x plus 4 is 0. While when x is equal to 2, x minus 2 is 0. Using a test point from negative infinity to negative 5, we have 0 for 3x plus 4. Also, a test point at the interval negative 5, negative 4/3, 3x plus 4 is also negative. Any test point on the interval negative 4/3, positive infinity, 3x plus 4 yields a positive value. In the interval negative infinity, positive 2, any test point would result a negative value for x minus 2. While in the interval 2, positive infinity, substituted to x minus 2 gives a positive value. In the interval negative infinity, negative 5, substituted to x plus 5 yields a negative value. Negative 5, positive infinity, any test point will give a positive value when substituted to x plus 5. Multiplying all values in each interval, we have positive, negative, negative, and then positive. Hence, the solution to this inequality is the interval negative 5, or the closed interval negative 5, positive 2. And the integers, or the integer value for x in this interval are negative 5, negative 4, negative 3, negative 2, negative 1, 0, 1, and 2. Hence, there are 8 integers x that satisfy the inequality. Number 27. Circle C has equation x squared plus y squared minus 10x plus 6y plus 30 equals 0. Find the coordinates of its center. For our solution, let us transform the equation in the center radius form. So we have x squared minus 10x plus 25 plus y squared plus 6y plus 9. Then we have negative 30 plus 25 plus 9. X squared minus 10x plus 25 is x minus 5 squared, while y squared plus 6y plus 9 is y plus 3 squared. Then on the right hand side, we have negative 30 plus 25 plus 9, which is 4. Comparing this to the center radius form of the equation of the circle, which is x minus h squared plus y minus k squared equals r squared, the center is at 5, negative 3. Number 28. Find the diameter of the circle in number 27. From the resulting equation for the center radius form in number 27, we have x minus 5 squared plus y plus 3 squared is equal to 4. Then r squared is equal to 4. The radius of the circle is equal to 2. And since the diameter is twice the radius, the diameter is equal to 4 units. Number 29. In the figure, minor arc AB measures 80 degrees. AC is tangent to circle at A. What is the measure in degrees of angle BAC? From the figure, we know that the measure of angle BAC is 1/2 the measure of its intercepted arc, which is arc AB. And since arc AB is given as 80 degrees, then measure of angle BAC is 1/2 of 80 degrees, and that is equal to 40 degrees. Number 30. RS and CD are two chords intersecting inside the circle with center at X at point A. Measure of angle RAD is equal to 130 degrees. And the ratio of the measure of arc RD to the measure of arc CS is 5 to 8. Find the measure of arc RD. For our suggested solution, we know that measure of angle RAD is 1/2 the sum of the measure of arcs RD and arc CS. However, we are given the ratio of arc RD to the measure of arc CS as equal to 5 to 8. Hence, measure of arc CS is equal to 8 times the measure of arc RD over 5. Substituting the values, measure of arc CS is equal to 8 times the measure of arc RD over 5. And we know that measure of angle RAD is 130 degrees. Then we have 130 equal to 1/2 measure of arc RD plus 8 over 5 measure of arc RD. Then we have 260 equals 13 over 5 measure of arc RD. Then the measure of arc RD is equal to 260 times 5 divided by 13. 260 divided by 13 is 20, and 20 times 5 is equal to 100. Therefore, measure of arc RD is 100 degrees. That will be all. Thank you for watching. Please subscribe for more math contest videos.